You've seen a bridge bend. But have you seen a bridge that bends and still stands? This isn't just engineering. It's a dance between force and flexibility. Bamboo isn't just strong. It's smart. It bends without breaking, absorbing energy like a natural shock absorber. And that's why it's still used in construction today. What makes bamboo so unique? It's not just the fiber. It's the way it's structured, with a cellular composition that gives it both strength and flexibility. This bridge isn't just a structure. It's a living testament to nature's engineering. The way it bends without breaking is a lesson in resilience and design. So, what can we learn from a bridge that bends? Maybe it's not about being rigid, but about being adaptable, both in nature and in design. So what exactly are we talking about? We're discussing a type of beam made from bamboo that can bend without breaking. This isn't just any bamboo. It's specially engineered to flex under stress. The key here is the material itself. Bamboo is naturally strong, but its real power comes from its cellular structure. It's like a living fiber that can absorb and distribute force efficiently. This bendable beam is not just about strength. It's about flexibility. When you bend it, the internal structure of the bamboo resists breaking by redistributing the stress across its length. Engineers are studying this because it could revolutionize how we build. Imagine bridges or structures that can withstand earthquakes by bending instead of breaking. That's the real potential of this material. So, when we talk about the bendable beam's strength, we're not just talking about bending. It's about smart, adaptable strength that could change the way we think about construction materials. You might not think about bridges every day, but they're everywhere, supporting your commute, your city, even your coffee table. This bendable beam isn't just a cool material. It's a silent hero in our infrastructure. When we talk about strength, we're not just talking about weight. We're talking about resilience, how a structure holds up under stress, pressure, and time. This beam is engineered to do exactly that, without breaking. This kind of material could change how we build. Imagine bridges that bend instead of break, buildings that sway safely, or even furniture that's both strong and soft. It's not just about durability. It's about design freedom. And here's the kicker. This material is sustainable. Bamboo grows fast, uses less energy, and can be harvested without destroying the environment. It's a win for both your wallet and the planet. So, why should you secretly care? Because this isn't just about science or engineering. It's about the world we live in, how we build, how we move, and how we protect the future. This bridge is a sign of what's possible. Let's fast forward a few thousand years. The first bamboo bridges were built in ancient China around 500 BCE, where flexibility was key to withstanding earthquakes and heavy rains. Engineers used a simple yet genius method, bending the bamboo beams just slightly, which made them strong enough to support the weight of people and animals without breaking. This approach was not only effective but also efficient, using minimal material and labor to create durable, resilient structures that could last for generations. By the time the Tang Dynasty arrived, bamboo bridges were part of a broader engineering tradition that emphasized harmony with nature and material efficiency. Even today, modern engineers study these ancient techniques to understand how to make structures both strong and adaptable in the face of natural forces. Imagine the bridge made of sticks, but not just any sticks. These sticks are super strong and bendy, like a giant slinky. They can hold a lot of weight without breaking. These sticks are special because they're not just straight. They're curved in a way that makes them really strong. Like a spring, but for bridges. It's like when you bend a paper clip, the inside gets tight and the outside gets loose. Bamboo does the same thing, but way stronger. So the secret is not to make the beam straight, but to shape it just right. Like a banana, but for bridges. This is how the bamboo bridge stays up without breaking. It's not just strong, it's smart about how it uses its strength. Before we even touch the bamboo, we need to set up the right framework. This is where the foundation of our experiment begins. We start with a sturdy base, carefully aligned to ensure the beam is placed precisely where it needs to be. The beam itself is positioned horizontally, resting on two supports. This setup allows us to apply force to the middle of the beam, testing its ability to bend without breaking. We use a digital load cell to measure the force applied. This device connects to a data logger, which records every bit of stress the beam experiences as it bends. The setup includes a mechanism that applies force gradually and evenly. This ensures the beam experiences a controlled, consistent load rather than a sudden impact. All the components are calibrated and secured to avoid any unexpected movement. This way, the experiment remains accurate and safe for the entire process. Once the beam is bent, the bamboo fibers on the outer side stretch, while those on the inner side compress. This natural flexibility allows the bridge to absorb and distribute energy without breaking. The bamboo's cellular structure acts like a natural spring, storing energy when bent and releasing it gradually. This makes it resilient against sudden impacts or vibrations. This flexibility also allows the bridge to sway slightly, which reduces the risk of structural failure during high winds or earthquakes. It's like a dance between strength and softness. The bending motion also helps redirect stress away from critical points, preventing cracks or fractures from forming in the most vulnerable areas of the beam. In essence, the bamboo bridge's strength lies in its ability to transform force into motion, rather than resisting it. It's not about being rigid, but about being adaptable. The clever twist isn't just a design feature. It's a fundamental shift in how we think about flexibility and strength. By twisting the beam, we introduce a new kind of stress that actually enhances the material's ability to resist breaking. This twist creates a helical pattern of tension and compression within the beam, distributing force more evenly across its structure. It's like wrapping the beam in a spiral of strength, making it more resistant to bending and breaking. When the beam is twisted, it acts as a natural spring, absorbing and redirecting energy instead of letting it cause damage. This makes it not just strong, but also surprisingly resilient to sudden impacts. The twist also changes the beam's center of gravity and its moment of inertia, which means it can handle dynamic loads better than a straight beam. It's a subtle but powerful reconfiguration of its structure. In essence, the twist turns the beam from a rigid structure into a flexible yet strong one, bending without breaking and bearing weight without snapping. It's a masterstroke of material science and engineering. So what's really making that bamboo beam bend without breaking? It's all about the way the fibers in the bamboo are arranged, almost like a network of tiny flexible rods. These fibers are arranged in a helical pattern, which gives the bamboo both strength and flexibility. It's like a spiral of tiny interlocking springs. But it's not just about the structure. It's also about the material itself. Bamboo has a high strength-to-weight ratio, making it both strong and lightweight. Scientists have even modeled bamboo's behavior using equations that mimic its natural flexibility. These models help engineers design structures that mimic its resilience. So, the science behind the bend is a perfect blend of biology, materials science, and engineering, proof that nature is often the best teacher. So imagine a bamboo bridge is like a flexible guitar string. When you pluck it, it bends but doesn't break, just like the bamboo beam resists bending without snapping. The guitar string's strength isn't in its stiffness, but in its ability to absorb force and return to its shape. Just like the bamboo beam's strength lies in its flexibility, not its rigidity. This analogy isn't perfect, but it captures how bamboo bridges use flexibility as a form of strength, turning what seems like a weakness into an advantage. It's gloriously dumb, but it works. And that's why we can build bridges that bend, not break, without losing any strength in the process. Before you go, if you enjoyed this, please give it a like, and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.